Ladies and gentlemen, welcome to our spring webinar series number 2. We're looking at some interesting topics today that seem to be as exciting as you can get for a new team particularly, and also for an experienced team. We're looking at the crux of building steering and suspension on your solar car. That's going to be brought to you by Jarrett Dunn, our race operations officer. We're going to meet an experienced solar car team, which is a Wylie East High School solar car team led by Tony Roseberry and his great team going to be part of this. Our second hour begins with the importance of the solar car project management, and that is huge. So many times you have great ideas and you're building and you're doing all of this, but how do you get your project from beginning to the race? That requires some considerable project management. And then I've invited 3 outstanding solar team advisors to come on and talk about how they're keeping their parents invested in the solar car project. So welcome to our webinar series. I have been very enthusiastic about the comments you have sent me about this. Thank you very much. We're trying very hard to keep you informed and your students motivated as we work towards building a great 2021 solar car challenge. So let me pass the program over to Jarrett Dunn, who's going to be talking to you about solar car steering and suspension. Jarrett?
Thank you very much, Dr. Marks. Let's get this presentation up here. Okay. Hopefully you can all now see the slides. So today's topic is solar car suspension. Welcome from beautiful scenic Naples, Italy. Forward to having you. If you have any questions, please throw them in the chat or the question and answer section, and we'll go on. Okay, so what we're going to cover today, introduction, which we're doing now. We're going to talk briefly about some different types of suspension. We're going to do some key terms. We're going to talk about measuring toe, which is one of the most important aspects of your steering and suspension. We're going to talk about Ackerman steering, and finally, we're going to conclude by talking about some of the best practices that we've seen over the many years that we've been doing this. So we'll start out with some common types of suspensions that you'll see. So the first one is a McPherson strut. It's something you see on a lot of your passenger cars. You also see it occasionally on things like golf carts. It's a very simple system, but it tends to be heavy and it tends to have limited adjustability. So it may or may not be useful to you in solar car racing, but it's definitely something you can consider. You can go out and buy the entire package and have it pretty much ready to bolt on and go. Another common one you see is a solid axle, where you have a single beam that runs across the car. Your wheels are bolted onto the end, and you use leaf springs to give you your movement. It's a very simple type of suspension. It's very common in things like trailers because really easy to do. It has both a benefit and a drawback that your suspension geometry is set. Once it's built, you can't really adjust it, which can be a good thing or a bad thing. The problem is most of them tend to be very heavy. Leaf springs by their nature are big pieces of metal, have a lot of weight to them. The crossbeam tends to be very heavy, so they come at a certain cost of weight to your solar car. Probably the most popular type of suspension for your solar car is the double A-arm suspension. It's a very versatile type of suspension. You have a lot of different ways you can adjust it. There are multiple angles, multiple adjustment angles with each of the rod ends or bearings. So if you don't manufacture things exactly perfectly the first time, you have a lot of opportunities to go in and adjust it and change it. Also, if you don't like how your solar car is running, you have the ability to tweak it a little bit. The downside is it's very complicated. With all those adjustments, you have lots of chances to mess things up, and you have lots of things to get out of alignment. And so some of the less common suspensions we see are a torsion axle. Again, these are very popular on trailers and lightweight vehicles. In a torsion axle, you have a piece of rubber that basically allows the suspension to twist. They have very little adjustability, and they tend to be very heavy, so we don't see them very often in solar cars. The radius arm suspension, okay. Things are popping up the screen, sorry. A radius arm suspension is very common in the back suspension of cars. Basically, you have a pivot point and a bar coming out behind you that allows your suspension to move up and down. Another type of suspension is a mountain bike front fork suspension. These are very lightweight, but they can't take a lot of load. They also have to be very careful. Bike suspensions are not meant to be loaded sideways. So if you design your suspension with a mountain bike system, it's very important to consider how your system is being loaded. And the last kind of suspension is a solid suspension, which basically is the lack of a suspension. The benefit of it is it's very simple, it's lightweight. The downside is you have no suspension. So,
Gerald, can I jump in there?
We have suspension.
Can I say something?
Please.
Our first solar car didn't have a suspension. We had a solid suspension, and it worked. The only thing is when we got through the race, the car had torqued and twisted and was permanently ruined. So we destroyed the car by not having a suspension.
Yes. And this is a discussion that William and I have had many times over the years, that whether or not you need a suspension. You know, there are ways you can get away with it, but you need something. The purpose of a suspension, we tend to think of suspensions for driver comfort, but really that's a side effect of what a suspension is for. Really, the suspension is to keep your wheels on the ground and to keep your car in one piece and allow you to steer it. So if you don't have a suspension, or if you don't have tires that are capable of absorbing bumps, every time you go over a little bump or inconsistency in the track or road, your wheels are coming off the ground and you no longer have control of your vehicle, or you're no longer applying power to the road, you're just wasting energy. So it's one of the reasons we don't put it in the less common suspension type, and we don't see it very often nor really advocate for it. Okay, so in talking about suspension, there are a lot of vocabulary, and it's important to know the right terms, what we're talking about. In the end, all these things are adjustable, and there is no right answer, but you have to have a frame of reference to have a conversation about suspension. So I've done suspension design and setup for a long time, and in college, I worked for a race team. And there are lots of ways to set up a race car. There are rules that are considered correct. But the son of my owner was a really good driver. But basically, we set up his car completely opposite from all the normal ways that you would set up a car. In fact, no one else could drive his car because it was so strangely set up. However, it's what worked for him. And he was incredibly fast and incredibly reliable in that car. So there are no right answers when we're talking about suspension. It's just what works for you. But in order to know what works for you, you have to be able to discuss it and know what you're working with. So we'll talk about some of the terms. The first is the contact patch. The contact patch is an oval-shaped area where the tire contacts the road. This is literally the proverbial where the rubber meets the road. And so in an ideal world, which doesn't exist anywhere besides your physics class, your tire is a perfect circle. Your tire touches the road at exactly one point. However, we don't live in a physics class, probably thankfully. We live in the real world. So in the real world, your tire has some deformation, and you get this oval-shaped spot on the ground where your tire touches the ground. So the contact patch is probably the most critical part of the solar car suspension. As I said, this is where the rubber meets the road. It's the only place where you can apply force to allow your car to brake, to turn, or to go forward. So it's critical for steering, handling, braking. It's affected by the tire construction, the tire pressure, the type of tire, the radius of the tire. So basically, the smaller your contact patch is, the more efficient your solar car is going to be. The downside of it is, the smaller your contact patch is, the less force you have to turn the car and the less force you have to stop the car. So there are trade-offs in all of these things. So you might have a car that's really efficient, but you can't stop. Conversely, if you have too much of a contact patch, you might be able to stop and turn very effectively, but you might be losing a lot of energy that you could be using to go forward. And as we know, solar car racing is all about being efficient. So it's also all about trade-offs. So finding that right balance is important for you. And you can adjust it by, the main way we adjust it is by playing with the tire pressure. So the next term is the steering axis. And the steering axis is the line between the two pivot points of the wheel. And as you can see in the little drawing, those two pivot points on the top and the bottom are where the upright connects. You extend that line from infinity to the bottom to the top, and that's your steering axis. That's the wheel, the road, that's the axis around which your tire is going to rotate as you turn the vehicle. And that will come back for being important in a few minutes. So the next one is toe. And toe is the angle of the wheel relative to the center line of the vehicle. So I'm sure that makes perfect sense to everyone watching because, but for most of us, pictures are much easier to understand. So as you see, we have the front of the car is at the bottom of the screen. And then we have the center line of the tire. So this is called neutral toe, when your tire is in line with the center line of the car. So if you have toe in, the front of your tire is pointed in towards relative to the center line of the car. If you have toe out, the front of your tire is away from the center line of the car. Okay, so what does toe affect? Toe has a really strong effect on tire wear. Toe out really improves steering. If you really want to dive into a corner, you can have toe out. And I talked about my former boss. His car actually ran toe out, which makes it really improves turning in. But can make your car really jerky. It really wants to dive into corners. It does not want to go in a straight line. So any little inclination off the center line and the car will dive in a direction. Toe in improves straight line stability. It makes your car want to come back to center and drive in a straight line. As we said at the beginning, excessive toe in or out causes your car to wear the tires out. So it's a balance. You don't want your car to turn too well, but you also don't want to wear out your tires because every time you have to change a tire, you're taking time away from your driving opportunity. Okay, the next term is caster. And caster is the angular displacement of the steering angle, as we talked about what the steering angle was before, from the vertical axis. And again, a picture is worth 1,000 words. So caster also improves straight line stability. Caster is positive when the steering axis is inclined backwards from the vertical. As we can see the picture. And well, I thought we had other pictures, but obviously, so if that's positive caster, negative caster is when it goes in the other direction. So negative caster improves straight line stability. So, and we have a question. Is there an optimal or toe or caster configuration for solar cars? So no, there's not an optimal toe or caster for solar cars. So all these things are a balance. You have to find out what works for you, what works for your car. I would say in general, you want a little toe in and a little caster, but there are no absolutes. So thank you for the question. So positive caster provides feedback in the steering wheel. It does, however, do this at the extent of making the car harder to turn. So your car is responsive, you'll feel what's happening with the wheels, but it requires more force to turn the car. It also causes the wheels to want to self-center. So if you have positive caster and you let go of the steering wheel, your steering wheel is going to come back to center instead of continuing in the angle that you're going or going off in a different direction. Negative caster just makes you unstable. One of the very few things we'll say is that negative caster is a bad idea. It's something you definitely don't want. Okay, camber is the angle of the wheel and tire with respect to the vertical axis. So we have a picture from our picture. You're looking from the front of the solar car, looking back down the car, and you can see the vertical line, and our tire is tilted inward. As you can see, this is highly exaggerated to be able to show the angle. Hopefully, you would never run your car with this much camber. So this would be negative camber, and this would be positive when the top of the tire is pointed out. Okay, camber affects grip and stability and cornering. So basically, as you turn your car, the car rolls, and if your tires were perfectly flat and had no camber, you would actually lift part of your contact patch as you go around a corner. So camber allows you, as the car rolls, to place more of the tire on the ground and increase your contact patch. Well, this is solar car racing. We don't exactly do a lot of high-speed turns. As we've pointed out in previous webinars, the average speed of the winning solar car tends to be in the 25 to 30 mile an hour realm. We don't do high banks, we don't do 1G turns. So in general, we don't use a lot of camber. So generally, and for reference, NASCAR, which are running 160 miles an hour on banks, pulling multiple G's turn, run about 2.5 to 3 degrees of camber. But what can be applicable to solar car is camber gain. So if you have non-equal lengths on AA arm suspension, as your suspension travels, the angle. Oh, I'm sorry, we have another question. Is this from the top view? For the camber image is looking from the front of the car, looking back. Does that answer your question? Okay, no follow on. So if you have a AA arm suspension with unequal length A arms, the camber angle is going to change as the suspension cycles. So you want to be aware of this so that your suspension doesn't change in dramatic fashion and change how the car is handling. Particular issues are solar car tires, or tires that are used on solar cars, tend to have a very specific spot in which you're supposed to have the contact patch. They tend to have a very thin line of hard rubber, and they tend to not have a lot of mass off of either side of the center line. And that's so that you aren't carrying a lot of weight that you don't need. But if your suspension changes as you cycle, you might find yourself running on a weak part of the tire and causing premature wear on your tire. Okay, and our last vocabulary term is scrub radius. And scrub radius is the distance between where the steering angle intersects the ground and the contact patch of the tire. So if you remember from earlier where we had the contact, or the steering axis, on the right, where the vertical line, or the line connecting the two pivot points, and you also have the point where your contact patch where the tire is actually touching the road. So scrub radius is the distance between those 2 points. And so scrub radius has some effects on your steering. And a good way to think of it is a little thought experiment. If you have a coffee cup and you just rotate it, it's very easy to rotate and the coffee cup doesn't move. But if you now take the coffee cup in your hand and rotate by your elbow, you have to drag the coffee cup along the table as you are rotating. So when you have scrub radius, when you turn the wheel of the car, you're actually dragging the tire across the ground. So scrub radius, the larger your scrub radius is, the harder it is to turn the car. It also increases wear on the tire every time you turn because you are now dragging the tire across the ground instead of just rotating it. But it does have a little positive aspect that it creates a force and creates the car to self-center. Okay. So with all these terms, one of the most important things for your car is to be able to turn properly. And for the optimal steering geometry has been calculated, it's called Ackermann steering. And basically, when you turn, your inside and outside tire need to follow different paths to make a smooth turn. And so if you want to make a turn around a certain radius, there's a way to calculate what the angles are that you need to have for your steering. So we have a defined turning circle in our rules, which you need to be able to pass in station 3 for our car. So we know what the center of our turning radius is. So with that, you can figure out the angles that you need to create it. And it's very simple. If you draw a line from the center of the rear tire to the steering axis and draw a line, your steering points need to be along that line, and that will give you Ackermann steering, which will give you the optimal ability to turn without dragging a tire as you rotate around that circle. Okay, so we talked about toe. Toe is probably the most useful measure that you're going to have for your car, and it's definitely the most adjustable thing, and the thing that tends to cause the most problems for solar car teams. So in order to talk about toe, you need to know how much toe you have in on your car. And it's actually very easy to measure and calculate. So to measure toe, you can do it with some very simple tools. Two straight pieces of metal or wood and a ruler, and you can measure your toe. So if you put your pieces of metal or your straight edges against the tire, and then you pick 2 points and you measure across them. So you get one distance, and then you get a second distance. If you know the distance between the two measurements, then using a little math, you can calculate. But that's an overly difficult question. And a lot of times we don't actually care what the exact number is. You're looking for what works for you. So a lot of times we just simplify it to being the difference between the two distances. And that way we can say, I want to dial in 1/4 inch of toe. And I know that this is what works for me. And every time I have 1/4 inch of toe, or I want 1/2 inch of toe in, just do the distances. So the one thing about doing this is it's very important to be repeatable. If you're looking for 1/2 inch of toe, it makes a difference how you do this. So we just had one measure. So if you measure this distance, you're going to get a different measurement. And if the next time you do it with that measurement, you're never going to get the same number. And so you have to be consistent. And several years ago, I watched a team go back and forth. They had everything set up. They knew what they were doing, but they weren't being consistent with their points. And they were looking for 1/4 inch of toe, and they'd adjust it, and then they'd go measure it in 1 point, and it wouldn't be what they wanted. They'd go adjust it. Then they'd measure it with a different set of points. It would be off. And they fought it for the better part of an afternoon just because they weren't being consistent. So when doing all these things, it's very important to be consistent and use the same points. So I recommend, if you're going to set up this way, to make a dedicated set of tools, piece of metal or a piece of wood that's straight, and mark your points. Mark where your tire goes. Mark where the center line of the tire, or the center point of the tire is. Mark your A and B so that you use the same points every time, and then you'll get a repeatable measurement every time. There's another method of measuring toe, which basically takes two straight edges set apart from the car, 2 points, and then you just measure in from the toe. And you can build this tool with a couple pieces of PVC and some string. Very effective. This is actually how I still measure it when I go to the track to this day. And you can get the 2 points, and again, formula. So, best practices. Consistency is key. So be methodical in doing this and do the same thing every time. I talked about with measuring toe. If you don't measure it the same way every time, you can be chasing the numbers you want. You also don't know what those numbers are, what they mean if you don't do it the same way every time. And when you do it every time, take measurements, record them. It's critically important you know what the car is doing when it's doing it. Because as I said, there is no absolute right answer. You're looking for what works for you, for your drivers, for your team, and for what's efficiency. So you might set up a car and it might just work perfectly incredibly that day. And then if you don't record it, you don't know what happened. And if you have to change a tire or change a wheel and something changes, if you don't have a good measurement and you don't have a good methodical way of getting back to it, you may never achieve that same status again. And along with that, as we talked about, making dedicated tools so that you can be consistent. Very cheap, easy, and takes no time and effort. And as we said, solar car is about efficiency. We're not doing high-speed turns. You don't have to dive into a corner at hundreds of miles an hour. Our braking is not pulling multiple Gs. So in general, small or zero angles are fairly optimal for solar car racing. So you want to make small changes. Small angles and make small changes as you're doing them. And test what works, make small changes, see what works for you, and then continue on making small changes until you find what absolutely works for you. Okay, and some references that this came from. My particular favorite is the Winning Solar Car by Douglas R. Carroll. It's at the college level, it's called the Solar Car Bible, but it's a very good book, and I highly recommend it to anyone who's interested in solar car racing. It's there's a lot of math in it, but it's also very approachable and very good explanation of concepts about solar car racing and how all these things affect you. And that's all I have for this today. Does anyone have any questions?
Jarrett, thank you for an exciting presentation. I always like the way that you set things out because you have a nice way of being able to explain things in just enough detail for us laymen to be able to work with it. So you have my appreciation for it. And please don't hesitate to send in questions on this. I'm delighted now for us to have the opportunity to meet with the Wylie East Solar Car team. They're going to be talking to us about their car. They're going to be showing us some of the cars, a video of their car, and you get a chance to meet the team and their great advisor, Tony Roseberry. Tony?
Are we there?
You are.
Very good, very good. We're really happy to be with you guys this morning. We appreciate the opportunity to have a few minutes to share some things about our car and our history and our team. And we put together a little video, and we'd like to show that to you first. And then afterwards we'll have some explanation on, or during the video, we'll have some explanation on how the car was put together and some things along those lines. So let's go ahead and play the.
I am Claire McDaniel, and this is actually my first year on the Wylie Solar Car team. However, I am a certified welder and got my certification last year. I pretty much help out with everything like CAD drawing, safety, windshield, steering, stuff like that.
My name is Jacob Price. I'm a senior. I've been on this team for 3 years. I'm the co-captain and the team lead for aerodynamics.
My name is Nate Reiner. This is my first year on the team, and I mostly just work like minor problems and like securing down the battery pack and just helping out around generally.
Hi, I'm Noah Reiner. This is my 3rd year on the Solar Car team. I am mainly in charge of designing, implementing, and building electronic components on the car, mainly cruise control, telemetry, and the aux system.
I'm Travis Gunter. This is my 4th year on the team. I'm co-captain this year.
My name is Mo, and I am design and build team.
Hi, I am Alil. I am the driver, and I also work on the car hardware-wise, so just anything physically see, I ignore the electrical stuff because I will zap myself.
My name is Tony Roseberry. I'm the advisor for the Wylie East Solar Car team. I was wanting to tell you a little bit about the history of the team. We began racing in 2013. We began building the car that year with the hopes that we'd be able to race that summer, and we were an absolute failure. We didn't know what we were doing, how to do it. We didn't even have a car that would run. So 2013 comes along, we got the car running. We got 10th place that year in a race to California. The reason we got 10th place is because there were only 10 teams. If there had been 15 teams, we'd have been 15th place. We went from an absolute failure in 2012 to a team in 2013 that was absolutely horrible. We drove out of 900 miles, we drove approximately 100 miles. We drugged that car most of the way to California. 2014 rolls around, we made some improvements, we'd learned some things. That year we moved up from 10th place to 8th place. I think there were 12 teams in the division. So we made some improvement, but we were still horrible. 2017 we returned. We got 4th place that year. It was a much better team, it was a much better car, and we were excited to have gotten to that point, 4th place. We were better than we had been before. 2018, we took another trip to California. We ended up in 2nd place on that trip. Great improvement. We still lost by 60 miles to the 1st place team, the Solar Cats. We blew a motor on the 6th day of the race and lost about 40 miles. We were still lost, but we managed to get a motor on and finish the race, so ended up 2nd place. 2019, we felt like we had 1st place wrapped up. We had a great car, we had a great team. We led the race for 3.5 days. On the last few hours of the last day, the mighty engineers from Prosper caught up to us and beat us by 2 laps. So every year we've gotten better and almost had a 1st place in the bag in 2019, but that was not to be. We're rebuilding another car this year. It's a much better car. We're hoping that this year will be the year. So I would say that one of the reasons that we have improved through the years, besides the fact that we just didn't quit, was the association with great teams, teams that know how to do stuff. And I want to give a big thank you to the Greenville Solar Car team for all of their help and all of their encouragement and all of their willingness to teach and train other teams.
So this year we've had a complete redesign for the car. We went through 3 design iterations. So for this design now, we've kind of incorporated everything. We have the really rounded front nose from the whale design. We have the smooth lines seen here on the spaceship design with a sharp back with a spaceship design, and kept the hull of the original design.
So this year we went with a lighter, smaller car, so it'll have more efficiency, and that'll help with our newer panels and batteries, so it'll be able to run longer, faster.
So basically the original way we had the steering system, it would be so it'd feel like it was turning like a boat. But with the system Claire designed, we were able to make a steering rack. This is similar to what a go-kart steering wheel would look like. It acts kind of like power steering, so you can kind of turn it easily, even with your finger. Just makes it easy to drive. Basically how this works is when you turn that wheel, that sprocket will go down here, turning another sprocket, which then transfers that momentum over to a gear. It's basically, as soon as you turn the gear, it'll push out a piece of metal that then pumps this, which will then act on this rod, which will act as a pushing force outward towards the tire, which then allows it to turn and have a turning radius of about 35 degrees, give or take on the circumstances.
And with a lot of trial and error, we created a prototype of this steering system. I designed it in Rhino drawing program, and we had to take a lot of measurements to see where the gears and the position of it would fit into with the new steering system as well. And so we had to make sure that everything was adjustable, and now with this new steering system, we are able to steer the car with a lot less force.
Hey guys, my name is Mo, and I'll be explaining suspension to y'all of the car. Okay, in the front we have a solid axle on 2 bike forks. We use bike forks for 2 reasons. It completes the simplicity of the car, and also it covers both sides of the wheels. The way it works with the steering is connected by a steering bracket. On to the back of the car. The rear suspension of the car is actually made of the back of a mountain bike's rear suspension. The way it works is connected to the wheel and axle, and the way it controls the suspension is by this coilover right here. And that is how our suspension works with the car.
Are we unmuted? There we go. Appreciate the opportunity to share some things about our car and our team. Students have worked hard, and we're really excited about the upcoming race. And we appreciate the opportunity to participate in this great solar car challenge. Thank you very much.
Tony, I have something to say.
I'm happy to entertain some questions.
Tony, I really enjoyed your presentation, and particularly your comments about the mighty Prosper engineers. I know they're watching you today and seeing the latest things that you're doing, but they're going to be on in 2 weeks doing the same thing. So you get a chance to see them. So this little give and take between Wylie and Prosper probably is going to continue for next year. So congratulations. You did an excellent job. I really enjoyed watching your students do their presentation. They know what they're talking about, and you've made leaps ahead on this.
Thank you very much. Thanks again for the opportunity.
Thank you. William, our next section of the program deals with the importance of solar car project management. I think we're a bit ahead of time here, but we might as well go ahead and move into this section. So let me introduce William Shee, who is Race Deputy Director, who's going to be talking about these key things that help you get from the build stage up to the race stage and all the things that go along in the process. A well-directed project makes it easier for both the students, the parents, and the teacher here. So, William, I turn the program over to you.
Thanks, Doc. So I love talking about project management because it's not just a solar car skill. It's a skill that you need as an engineer in the professional world. When I was developing software for Raytheon, at one point I got to be the software team lead, and you had to go and plan out, these, defense contracts are, 3, 4, 5 years long. How do you actually get everything done in time? And how do you track that you're making the progress you're planning to make, so that you can deliver everything on time? It's the same process with solar car racing, right? Solar car racing, it's a year-long, or maybe for some teams, 2-year-long project. Well, how do you make sure that you can have a solar car ready by the time the race comes around? And so how you do that is project management. I like this quote that Stephen Covey says is, all things are created twice, first mentally, then physically. The key to creativity is to begin with the end in mind, with a vision and a blueprint for the desired result. And ultimately, what that's really saying is you've got to think through how you want it to look like, what your ultimate design is, what's your ultimate outcome you're looking for. Plan that out, and then you can manifest it in physical form, right? And so you've got to have that vision for where you want to go and the blueprint of the desired result, the design, how you plan to do it, and then you can execute to it. So solar car projects are really complex, right? It's not like you can just put a solar car together in a few weeks and call it done. It's not that type of project. I know when I first started working on projects, I did these little balsa wood structures, or these straw projects where you try to protect an egg, egg drop, project. Things like that are projects you don't really need project management for, because you just say, I've got a task, I've got to put it together, here's my design, execute it, and go ahead and do that. But solar car projects are a bit more complex. You can see with the Wylie East team, with other teams, they break out their teams into different areas of the car. Those who are in charge of the mechanical, meaning the suspension, the steering, the structure of the car. You've got an electrical team that looks at all the electrical components, the motor, the controller, the batteries. You have a power team maybe that is dedicated to solar arrays and how it charges the batteries. You'll likely have a business or outreach or community team that really knows how to go out and raise money for the car, make presentations to the community, get people excited, have a group of people that can reach out and share with the community what you're doing, right? So how do you coordinate all that work between the different teams? That's what project management comes in. Solar car projects take a long time. We already talked through that in terms of it could take 1 to 2 years. And it may require development of new skills, right? Not everyone knows how to build a solar car up front. And so you need to plan for the idea that you have to train people how to do certain things. If you don't already have a certified welder like Wylie East has, well, how do you make sure that as you build the frame, you have someone who knows how to weld? As you put your electrical system together, you have people who know how to solder, how to put crimp connectors on, all that stuff. That's part of the planning process. So when you look at that, when you have the multidisciplinary teams, how do teams work together? When you have a project that takes a long time, how do you ensure that the project is done on time? And how do you ensure that the teaching resources are appropriately allocated? So that's what project management gets you. It essentially breaks up this really large task, like build a solar car in time for a race, into smaller pieces. And then you start ordering those pieces into an order that allows you to know from here to there, how do you get there, right? You flesh out dependencies between teams. One of the things in engineering that they do is just-in-time manufacturing. And the idea is that if you plan your project out, you want to make sure that all your parts that you need, the raw materials you need to make a particular component, is there in time for you to actually build it together. And professional companies, they don't want to go and buy everything up front, because then they'll just sit on the shelf and it might take space, it might take cost. And the same with solar car racing, right? You don't want to have to buy every single component in your solar car up front, because you might not even have the money to buy everything. So how do you know what to buy at what time? This project management planning, it will help you say, okay, I'm going to work on these tasks at this time, so I better have the raw materials I need to provide for that task. Separately, it sets trip points for evaluation. One of the key things that you need to do in solar car racing is to know, am I on track for getting to the race, right? You want to be taking stock of where you're at in your development process and need to maybe reallocate resources if certain things are behind schedule. You don't want to get to the very end and say, hey, I'm just going to work, normally whatever tasks I decide to work on, I get to May, June, July and say, wait, I'm not done yet. I have a whole bunch of people sitting around because they're, mechanical folks, but all the electrical stuff didn't get done. And so I have no car, right? And so having tasks and milestones or trip points allow you to keep track intermediate, to the final race point and say, yeah, I can get there and I'm on track to get there. I'm behind schedule. I'm ahead of schedule. Finally, project management helps to prioritize your work on the week-by-week basis. If you can break down your complex tasks into smaller and smaller pieces down to what am I going to work on any particular week, then you can have a task list that you can check off. And we'll talk you through that in the upcoming slides. But the concept is you want to do things that are on the critical path. And critical path is simply a concept in project management that says there is a sequence of tasks and dependencies that are that will drive your schedule. Meaning that if a particular task was slip a week, then your entire project slips a week. There are some tasks that may not be so critical that you still need to do, but if that task slips a week, then your overall project schedule doesn't slip. And so you want to make sure that you're prioritizing your work on the critical path, not neglecting the rest of the tasks, because those tasks will get onto the critical path if you ignore them long enough. But you want to focus and say, how do I work on the things that are on the critical path? You might start going, wow, that's a lot of work in planning, and I'm not even building a solar car, I'm just planning. Well, how do you do that, right? So one of the things you can do is to start looking at our project planning calendar. We provide a resource for you to say, if you've never managed a solar car project before because you're a new team, how do you lay things out? And we give you some notional schedule about organizing a team, doing some preliminary design, and so on, all the way down to racing. And you'll notice one of the key aspects of this planning is you need to allocate enough time to test, right? Notionally, we are recommending that during December to March, you're prototyping and building, but that in April, you may go and say, well, my prototyping doesn't quite work. I need to re-engineer, this part or that part. That might be something to consider. And then we say, allocate enough time to test your final build so that you know how the solar car works, right? You don't want to show up at the race and say, ooh, how fast can I go, any particular time? How much energy am I going to expend by going this speed and the like? You want to be able to characterize that up front. And if you do that, you will arrive at the race prepared. Okay, so when you start looking at the construction, which is the key part of a solar car project management, how do you develop a timeline? So one of the things you can look at is break up the project into its major subsystems. We talked about the teams, right? The mechanical, the electrical, power, and business. And then from there, you can break them down into smaller pieces, right? On the mechanical side, you've got a frame, you got suspension, steering, brakes, drivetrain, and so on down the line. And then you start looking at those major components and tasks, and you go, okay, well, are there dependencies between the two, right? Imagine trying to do your steering and your brakes without a frame. You have nothing to hang it onto, right? So you know that up front, the frame is your very first thing, and then it drives your suspension, your steering, and your brakes. Well, and likewise, how do you steer the car without the suspension? Because the suspension, unless you have no suspension, you need to have some connection points on your tire, and your wheel, and then you start doing your steering rods, right? Likewise, you can throw your motor and controller on your solar car, but without the batteries and the wiring to hook it all up, they're just there, right? And so there are some dependencies that you naturally notice between subsystems. From there, you draw out those dependencies, and then you start breaking out those, subsystem components down to the tasks. Well, if I am going to put a suspension system together, I will need to, let's say I'm doing a double A-arm suspension, I'll need to design it, see how it looks like, see what components are needed, fabricate the A-arms, connect the shock there, mount it to the kingpin and to the wheel. There's a set of smaller tasks that you can break down, right? And so you'll need to break those tasks down and allocate time to do it. How long do we expect that each task to take? And then again, make sure you finish by March so that you have some leeway. What I said, critical path, critical chain, is tasks always tend to take longer than you expect. And so you want to make sure that if tasks slip, you don't slip into the race schedule, right? So one of the strategies of project management is be a little aggressive. We call it in planning doing a 50-50 schedule. You want to lay out your task with a duration that says, I have a 50% chance of making it, and 50% chance of slipping, right? And so that gives you a bit more aggressive schedule. And then you leave a whole bunch of buffer space at the end to say, if I don't hit the 50-50 mark, then I'll slip it a little bit and I can still finish on time. If you don't do that, and if you sort of lay out your schedule with like 100% confidence, then if you start slipping out, you end up losing the time, and you might not make the milestone you're looking for. Additionally, if you give a student, hey, you have 10 days to do this task, how long do you think they're going to take to finish that task? They're not going to finish it in 5 days or 7 days. They're going to take all 10 days to do the task. And then you don't have a chance to bring your schedule in, even though if they could finish early, we can get to other tasks, right? So plan aggressively and, challenge people. I know when I was advising and even when I was participating in the solar car team, we would challenge each other. It's like, we have 1 hour to fabricate this part. We don't think it'll take an hour. We think it might take 2 hours, but we're going to do an hour. And we start sort of racing one another and challenging each other to get the job done. And hey, it might get done in an hour, 15 minutes, but it didn't take 2 hours. So something to consider there. And don't eat into your re-engineering test time. Make sure you plan for that in your schedule, and make sure that you track your progress, that you don't, as things slip, eat into your re-engineering time.
Can I say something, William? I'd like to add an example of how this really has an impact on teams. In the 2019 race, there were 3 teams that actually arrived at the race and had not completed their car, had not tested it. Those teams didn't qualify, and it's only because they had so eaten into their re-engineering and testing time that they weren't ready when race time came. So this is crucial. Just supporting what you said.
Yep, exactly. That's ultimately the risk, right? If you don't plan things out and you don't track it, you may just end up running into the race schedule, and then you, even if you bring your car to the race, you may not get to race, right? So you want to make sure that you can have enough time to complete and test your car. So when you look at breaking down these tasks into subsystems and laying it out on a schedule, it'll actually look like this, right? So we break out the tasks out into, let's say, the frame, the roll cage, the axles, the seats, and so on. And you say, I'm going to take, a week or 2 weeks to do certain things. If you look at the grid lines, I sort of arbitrarily put it a week at a time, right? And so my notional schedule will say, I'm going to take 2 weeks to do a frame. I'm going to take 2 weeks to do a roll cage. I'm going to take 4 weeks to do electrical design, and so on. And then you start laying in proposed schedules and dependencies, right? So my notion is, you can't really do a steering without your suspension and without a seat to put in so you can sort of know where your steering wheel belongs. That's just sort of an arbitrary dependency, just to show you as an example. And so I say, okay, I'm going to draw these arrows to show the dependencies. And if the front axle slips to the right, for example, then all the tasks that are dependent on it also shift, right? And so you start laying things out and you say, oh, there are other dependencies. I've got my mechanical team working on things in yellow, but I know that the electrical team is dependent on me to have the motoring controller mounted so that I can wire it in February, right? And so you even look at dependencies between teams and say, oh, I better finish this at this time, or else the other team who's waiting on me will have nothing to work on. So that's how you lay out a particular schedule. And these are sort of high level tasks, right? These tasks take more than 1 week to complete. But this gives you an overall plan to say, okay, if I do all these things, I can get a solar car. Then the next thing you do is you break it down into smaller pieces. So we break that down and say, okay, what does steering mean? Steering could mean that I've got to design the steering itself in terms of location of the steering wheel, the rack. You may have to install the wheels, install the rack and pinion. So you start breaking down to smaller tasks into something that could be achievable on any given workday, right? Ultimately, the way we run our solar car team is we have a whiteboard on our in our shop where on any particular workshop day, we have a whole list of tasks, and we assign those tasks to individual, team members and say, you're responsible for this, you're responsible for that. And when they're done, they get a nice check off and say, yes, I'm done, right? And you get a sense of accomplishment. The psychology is that if you can continue to make progress, can you show, hey, yeah, I got this done, I got this done, you get motivated to keep working. But if you have tasks that take like a long time to do and you never get it done, you go, why am I spending all this effort to do this task? It takes forever. But if you can break it down and say, I finished this, I finished this, I finished this, it really gets people to do well, right? What you see on the screen on the right, which might be a little hard to see, is a proposed or a particular list of tasks on any particular week. We're working on 2 cars at the time. There's probably a set of 15 items for advanced division car and 7 items for electric solar car, right? And so you just sort of start checking off and assigning things to people. Some of these tasks are there from like a previous week we didn't complete, and so they stay on the task list. Some of them are new. Some of them we can't do. Like the second item there says install dual potentiometer for cruise control, a waiting part. And so we sort of just say, okay, it's on our task list. We still have to do it, but we can't work on it today. And so we sort of don't assign that task, right? And so that level of organization really helps us make sure that all our team members have something to work on and they can take credit for. So what does that look like in detail? Here's our example workday, right? So in a different list on a different day, here's a set of electric solar power division tasks for our car, and then there's a set of advanced division tasks. And so, you know, when you break things down to that level of detail, you can likely just say to any team member, go do this. They may have questions, right? About like, oh, how do I actually, you know, fabricate this? What's the length of the steering rod, for example? They can ask these questions, but I think the tasks are broken down into a sufficient level that you can give it to someone and they'd say, oh yes, I know how to do this, right? Of course, in project management, you go, okay, here's my plan. I'm going to execute the plan. I'll get it all done, no problem, right? So you get all the tasks identified. It'll finish on time. I'll have plenty of time to test. Well, that doesn't usually happen, right? One, there are always unplanned tasks, right? If you knew every single task that you needed to complete in your solar car, you must have done it like for decades, because there's, you know, you must have basically planned out your entire design and know exactly how things are going to run. But given that you have new designs and you have things that you sort of draw on paper, sometimes the paper doesn't come out to reality. And so when you start actually doing things, you might see some conflicts or issues with what we call the preliminary design, right? You draw it on paper, and then when you implement it, it may have issues you didn't see on that paper. And so you got to account for those type of tasks. And so for us, that task list that you saw on the last slide is really going to be updated on a weekly basis. And then we call that a living schedule. Likewise, you may have tasks that just get delayed. You don't finish what you expected because of certain circumstances that come up. You may have some things that you didn't estimate properly in terms of the task. It might be more complicated than you expected. It always gets harder. It doesn't get easier, unfortunately, in terms of tasks, right? You say, oh yeah, this is really straightforward. And then you start doing it and it's like, oh, wait, I didn't think about this or that. And so, you know, you got to plan that tasks will slip. And that's why I said earlier, you got to be aggressive in your planning. You know, you got to challenge people to take less time to do it so that it slips and you can actually finish in your plan schedule because you plan so aggressively up front. So in summary, in terms of project management, the key part of project management is to be able to assign your tasks and track progress, right? As you develop a set of task lists, as you develop your overall high-level project schedule, you put milestones in place to say, okay, am I on track to finish all those high-level tasks in time, or do I have to reallocate resources? And we didn't talk too much about resources, but let's say I have a mechanical team and an electrical team. And I'm doing really well on our mechanical tasks because they're more straightforward per se, right? And the electrical team, maybe they've came up with some issues and they're taking longer to do. If you don't reallocate your team members, you may end up having a bunch of mechanical, you know, team members sit there and say, I'm done, and have nothing else to do. Whereas your electrical folks are like, I've got so much to do, I need more time. So resources are simply the people or the money or the parts that you put at this particular task. And you say, oh, as I track things, I see that my mechanical team is ahead of schedule, my electrical team is behind schedule. Maybe I can pull a person or two off my mechanical team and put them on the electrical team, right? And that sort of continues to keep making progress on the schedule. If you do project management properly, you'll identify dependencies between tasks so that you make sure that the tasks that you're dependent on are done in time for the following task. And it ensures that parts are available, the just-in-time manufacturing stuff. If I know I'm going to be working on the power trackers, in March, if I'm buying them from Australia, for example, I better make sure I order them, in October, November, so that I can get all the order, all the shipping, all the customs and everything all scheduled so that when it gets to March, I can go install those power trackers, right? So that's part of your planning as well. And then be ready to modify your schedule. That's why we wrote our schedule on a whiteboard. We never had a like, here's my stone tablet that has my list of tasks for the week. You're going to change things. So just be prepared to do that. And then budget schedules for contingency. Don't end your project management schedule in July, right? Set some time so that when tasks slip, you can recover and still make it on time. So I hope this was helpful to you in planning out your solar car project. And I'll open it up for any questions that you may have.
I'd like to make a comment myself. I think it's a really good thing to occasionally reallocate your human resources for the reason that you don't want everyone to get to the end of the project and be so specialized that they can only do one thing. You want them to get to the end of the project and have a pretty good working knowledge of what's going on, so that if they're electrical, but you need something quick on mechanical at the race, you've got more than one or two people who are there working on it. So an occasional reallocation of resources can be a good thing.
Exactly. Yeah, and these are not comments on how you want to run your team. You certainly, I don't want to have a dedicated mechanical team that's all they do, a dedicated electrical team and that's all they do. You really want to have cross-trained people who can just sort of change between different teams.
I got to add that I had a student in one of my own teams who we were having a difficult time and we're trying to get things all fixed up. And I turned to him and said, I need your help here. And he looked at me and he said, but Doc, I only do wheels. So you don't want to be in that kind of situation. Or when somebody interviewed one of my team members, they were talking about their specialty, but the newsman asked them about something else. And the student said, I don't know anything about that. So you need to make sure that everybody has a pretty good overall understanding of the project. Well, I think it's time for us to move on to our last section of our program today. And that is something that I think is hugely important. When you get ready to start a solar car project, you know that you've got to make a proposal to administration. You've got to get your principal. You've got to get whoever is in authority in line with what you're doing and approving of it. And you maintain a relationship with them with periodic reports, or you bring them in to see what's going on in the shop, or you share the joys of the project. But sometimes the unappreciated group here, and maybe the most important, are the parents, because they have to be there to be able to support your kids. You're not asking these students to be there just during school time. There's going to be other times that are going to be hugely important for a parent to be able to bring a kid up to school on the weekend, or to make sure that that student's available during the summer to be at the race. This last race at the Speedway, there were a number of students who couldn't take part because somehow along the line, nobody mentioned that they were going to have to do this during the race and during July, and the parents had planned vacations. So you need to make sure at the very beginning of your project, you bring in your parents, you bring in administration, you let the team share what's going on, give their goals, their perspectives, timelines, and get a good idea and support for them, because there's neat things parents can do, like provide food, provide support, help you when you're doing displays. So to give some real meaning to this, I've invited 3 veteran high school solar car advisors to be with us today. We have Shannon Calloway from Covenant Christian Academy, Charlene Olson from the Winston School, and Marianne Varner from Martin High School in Arlington ISD. And I am inviting them to take a few minutes to share some of their experiences. Charlene, why don't you start this off today? If you'll unmute your screen and share what you'd like to do, what you'd like to say.
Well, I did have, good morning, everyone. I did have a short PowerPoint that just showed pictures of the parents, but I don't seem to be able to share that.
Well,
Yeah,
Charlene,
it just,
tell us a little bit about your team. And I know that y'all have been working in shifts in the shop there, but how have your parents been there to support you?
the parents are a key. The parents help, they're the roots of the team. When we are at the beginning of the year, I normally have a meeting. This year was different. It was a Zoom meeting. Communication with the parents on a weekly basis. I have Group Me specifically for my parents. I also text them. I send pictures. I want them to be a part of it. I want them to see what their child is doing, what their child is learning. Because when they enter the Winston Solar program, they're a little apprehensive at times, they're not going to do anything. They're just wanting into it to drive a car. But once they progress into it, I'm sending videos and pictures of their child welding, of doing electrical telemetry, and it gets them excited. It gets them more involved. Group Me has been a wonderful.
Charlene, I think you have hit a mute button. We can't hear you.
Can't say enough about the commitment of my parents. When I accept a new solar team member into my solar program at Winston, I have to have the parents on board. The parents have got to be able to be there too. I share with the parents the commitment, the time. We work Saturdays, 8 to 12 hours. We might work a Sunday, spring breaks, winter breaks, summer after school's over. I do give a few days off for a break, but it's full force pretty much all summer. And they understand that. Parents, I'm reliant on parents to run for parts, to help us with food runs. They even keep us organized. It's the parents that I also train to drive the truck and the trailer. They practice backing it in and out to assist us in cost of not having to have a driver. We also have an area that parents feel like they can't always be there every time I'm requesting. They're donating parts. A good example was one of our Briggs Stratton engines burn up. And the next thing I know, a parent had shipped at his cost and his expense 2 motors over $1,200 to us, and that was a surprise. In the holiday seasons, sometimes parents they'll ask for a Home Depot or Lowe's tool list because we're always misplacing our wrenches and such. And the next thing I know, we've got new wrench sets coming in. They also are part of our sponsoring. I have two parents that sponsor between $5,000 and $8,000 a year. Others, again, they sponsor by their time, their commitment to the team. During the solar race, our first year, we were breaking down. There was parents that drove the hour and 45 minutes or 2 hours due to traffic down to Mansfield to Mouser. Trying to barter for a more reasonable price that includes breakfast. I can't say enough about the importance of parents participating, but it needs to also show your dedication and your passion to their students' learning and their experience. That's what also is the key to enhance your parents into even being more passionate than sometimes you feel you are. And I'm very passionate, but once the parents catch it, it's wonderful. I've never had a parent, I guess I'm lucky, I've never had a parent that has told me, I know more, or we need to do it my way. It's always been a cooperative and unity. So that's what I have to share.
I'd like to add one thing on this. You mentioned that you spend a lot of effort making sure that parents know what their kids are learning. They
Absolutely.
enjoy having a chance to see their kids doing things. So one way I did this back in the day was that I would ask parents to bring up a meal for us. We'd sit around a table and the parents were there, and they took such great joy. Parents took such great joy seeing their student participating with other students. Many times they don't get a chance to see this, and that's part of the learning process. I don't know a parent who wouldn't enjoy knowing that their kid is learning social skills, how to get along with other people in a productive way, doing good things. So that's a good way to bring people. I'm glad to know that you're doing it. And thank
And oh, sorry, Dr. Marks, real quick, I just have to share. You brought up parents do the food runs too, but one summer, 2019, I had most of my teachers on vacation with only my captain and co-captain around, and we were testing the car. We had a breakdown, and the father came in of my captain, Triton, and he goes, "Look, I don't know anything, son, but I will put a welding mask on and just hold the part for you to do the welding." And he came in for about 10 minutes, held the part, was amazed that his son was welding and knew exactly what he was doing, and then he left. Thank you for this opportunity to share.
Thank you for being here. Marianne, would you like to share what's going on at Martin High School in Arlington?
Well, there's not a lot to share. With our guidelines, we really honestly have not been able to touch the car since March. So with just the being in a public school, our guidelines are more stringent right now. But we are keeping in touch with video calls. And my parents are great because we are an academy within the school. So we have a strong parent support for all of our programs. We have our own booster club within the academy. And then my parents on the solar car team. In the 2019 race, I had several parent meetings. This was our first time. And I just basically came to them and told them what I needed. And I will tell you that Charlene was invaluable because I called her and I said, okay, what do I need to know? And she kind of gave me a breakdown. And I went to my parents and I said, okay, this is what I need. And they just stepped up and they said, okay, we'll handle meals. You don't need to worry about it. And they organized it. And I didn't have to have that communication. They handled it. So my parents are good with, whatever we need. And we'll just come in and step up and just take care of things. So, yeah.
You exemplify one of the things I believe in. we talk about this cooperation between teams, and that's huge because particularly if you're an advisor, you automatically, somebody waves a magic wand and you're supposed to know everything.
Yeah.
And that's sort of overwhelming. But you've got all these other people who've done it and are willing to share because they've been there. So thank you, Charlene, for participating in this and jumping in. And Marianne, keep up a stiff upper lip. You'd be surprised how many schools right now are facing this lockdown situation, but they're trying to find ways to work on it. We have a team in New Jersey that has been able to get their car out of their shop and are working in a parent's garage. So,
Yeah, we legally can't do that. And I'm not taking that liability. But yeah, I've talked to our principal and she knows, and we've talked with the kids. In addition to Solar Car, we have a Roboboat team, which is another interesting, I don't know if you've heard about that, but, and anyway, so they're kind of in the same situation we are. But we're working on keeping the kids pumped up, with, things are going to change. So we just got to hang tight. But yeah, it's been hard.
We're trying to help support our teams by putting on these webinars so that we can share and keep in touch. We are planning right now our late spring series.
Okay.
Right now we have January and February spelled out, but March and April is coming along. And I'm going to ask all of the team advisors for suggestions. For instance, one of the things we're going to do is have a student draw an electrical plan on a dry marker board, and then have someone come in and take that and make it into an actual mechanical drawing using a CAD program. It's nice to have somebody to be able to see that kind of thing. Awesome. Things along that line that are practical, but send me an email. Let me know what you want to hear for everybody who's listening. Shannon, I want to share a screen with you. How are you doing, young man?
Doing great. I just tried to share a screen. Can you see that?
Yes, I can.
All right. So what we're doing at Covenant Christian Academy, we're a solar car club. So it's really something outside of school, and it's purely parent advisor led. So the things that we're doing is, and what we've done for the last several years to try to get parent involvement, is we start out the year with an annual mass mailing. We make sure that all parents at the school are aware and invited from the outset. And what I like to do with this mailing is it gets it to the homes where the parents see it and can get excited, doesn't get filtered and everything, between students and them. And so we found that to be pretty successful. In that, we invite parents and interested faculty to an orientation meeting that we have. And I've got samples of each of these things in subsequent slides. I won't go through them here, but hopefully we can post them so you can see it. So that's what we do first. At the orientation meeting, we have a kind of an exciting presentation that sells the students and parents on the program. However, at the end of that, we set a very clear expectation about the commitment required. Because early on, or at least a time or two, we didn't do that as well as we needed to, and sadly didn't get the follow through that we had really hoped for. So we do that. Once we get past the orientation meeting and we know who's going to be on the team, as we go through the work season, we have weekly update emails to students and parents. In that, there's a section on what's coming up in the week ahead so that everybody can kind of understand what we plan to be working on this coming week. There's a section for current action items that need their attention so that parents can see, all right, I'm needing this, I'm needing you to sign off on X, Y, or Z, but certain things that need their attention. And then the other one, I think maybe this is one of the most important ones, highlights of what we accomplished since the last update. And these are weekly updates. And not only am I listing that, but there's a set of attached photos where the students can see, or the parents can see, their students in action that week. What did they do? And they can see the interaction we've talked about. They can see progress occurring on the car. and cars. As you get to the race, we try to invite parents, make sure and encourage them to come to the Solar Car Challenge. You know, assuming you got through the season with these parents, this is where you turbocharge their interest. This is where they get to, like, from kind of mildly excited to, oh my gosh, I can't believe this is this amazing. And an example of that, one of the students on our team last year was our board chairman's son. And, you know, the board chairman was kind of, you know, I mean, he was supportive, you know, but from the distance, he comes to the event and he is just blown away. He's like, man, I never could have imagined how amazing this was. So, you know, we try to get them there. We try to memorialize the annual experience with a team photo album for every student. My wife lovingly puts that together. And Shutterfly, that's something she does. And it's not just of the event, but it's of all of the progress of the students throughout the year. So they see we started with nothing and we wound up with a built car and then how we did with that. And then I think another thing that's important is to each of us as advisors or sponsors of this is to have a realistic expectation of parents. Parents are busy. They're very busy. They often have multiple children's activities that they're trying to juggle. And being a parent advisor, sponsor of this myself with kids that are in a bunch of activities, I'm reminded of this at my own home. So I think, and what I try to shoot for each year is hopefully I'm getting one parent out of 10 students on the team willing to become an advisor with me, to show up weekly, work with me, so that I'm dividing and conquering, you know, on the responsibility of working with students to keep things safe as we're working. And then the other 9 parents out of 10, hopefully they will stay involved in encouraging their kid each week to show up, be there on time, bring them to the, you know, our work days. And it's something I haven't done, but Doc suggested a while ago, I think I want to incorporate this going forward, is asking a parent to bring sandwich meals or something for us. I think that's a great idea to supplement, you know, kind of rotate that around. And I think that's a great way to add to that. So with that as an overview, I'm just going to hit a couple of quick examples here. And hopefully we'll be able to pass this, post this, and you can see it. But I show, you know, what I'm sending out in the mass mailings, how, you know, how we structure a brochure that goes with that, what I cover in the orientation meetings, and so that you can see, you know, how we're selling that to our parents as we, you know, have those. But one of the things, let me get slide 25 here. Part of what I try to do at the end of the orientation meeting is talk about opportunities for parent and teacher advisors. And I say, you know, look, team advisors is a great opportunity for you as parents. Shannon, myself, I'm a parent advisor, and I definitely appreciate all the help I can get. Even more so now because we've been fielding 2 teams. We fielded 2 teams in 2019, and we plan to this year. And we, you know, I talk about the need for that and invite them. And then I talk about the need for parent help at the Solar Car Challenge event itself. We're needing parents bringing meals, setting up tents, taking down tents, all of those things. Then I tried to lay out the idea of a booster club and see if I could get some parent support on that. I haven't quite achieved that yet, but it's a goal out there that I'm trying to put in front of parents. And then the weekly update emails, I provided a sample of what I'm sending there. So you could see, this is just one from a week in February of last year. And then the photos that I send out attached to it so that parents can follow along with what's going on. And that's kind of what I'm trying to do at Covenant Christian Academy.
All 3 of you have outstanding programs, and I'm delighted that you are willing to share this with everybody who's watching. I hope that everyone will do one thing for me. Share with me what you're doing so I can put it out in our monthly newsletter. Send me stories, send me pictures, photographs of your teams working, because it gives hope to other teams who may not be able to work. There's something about seeing other people being involved that is encouraging and motivating to everyone. So I look forward to having everyone be more of a part of this. We're doing our best to create continued and new paths for motivating and sharing information. Come be a part of this. Well, that's our program for the day. I'm looking forward to getting your comments and look forward to seeing you in 2 weeks as we continue our spring webinar series. Thank you, Charlene. Thank you, Marianne. Thank you, Shannon. Thank you, Tony, for being a part of this today. Much appreciated.
You're welcome.
You're welcome.